Hello students, today I will explain another verbal example of LPP. Before that, remember the method. First we have to write the mathematical form of the problem using the information given in the problem, and then we can easily solve the problem using graphical method. So here also we first write the mathematical form. For that, let us read the question. A factory manufactures two types of screws, A and B. Here, the two types of screws A and B are to be manufactured in a factory. Then clearly, this is a manufacturing problem. Each type of screws requires the use of two machines, an automatic and a hand operated. So they have given the requirement to manufacture the screws. So this come under the condition. Further, it takes 4 minutes on automatic machine and 6 minutes on hand operated machines to manufacture a package of screws A. They have given the availability of machine or the information regarding the manufacturing of screws A and B. We will think about these information later while writing the table. Now we search for the objective or the aim of the problem. The actual question is, observe here, determine the maximum profit. We have to find the maximum profit, or the objective is to maximize the profit. So the objective function Z is to maximize the profit. We can consider Z as the profit function, and we know that the objective function Z is expressed in terms of X and Y. Now we have to choose the unknowns here. The question is, assuming that he can sell all the screws he manufacture, that is, the owner can sell all the screws that he manufacture, how many packages of each type should the factory owner produce in a day in order to maximize his profit? Now we have to find the number of packages of each type. Each type means here we have only two types, screw A and screw B. We have to find number of packages of screws A and B should be manufactured or produced in a day in order to maximize his profit. Number of packages of screw A and B are to be determined so that the profit is maximum, means we can denote X for number of packages of screw A and Y for number of packages of screw B. Now we have to find how many such packages, including both A and B, have to be manufactured so that the profit is maximum. This is our objective. So I have written, let X be the number of packages of screw A and Y be the number of packages of screw B. We can also write this as, let a factory manufactures X packages of screw A and Y packages of screw B. As here XY denotes the number of packages, they cannot be negative. So clearly XY are non-negative. They are greater than or equal to 0. And the objective is to maximize the profit. So here Z is a profit function. Now to write the expression for Z, we have to search for profit in the question. Here I have a profit. They have given that the manufacturer can sell a package of screws A at a profit of rupees 7. For selling one package of screws A, the profit is rupees 7. Here a factory manufactures and sells X packages of screw A. For X packages, the profit will be 7X. Similarly, for selling one package of screw B, profit is rupees 10. For selling Y packages, the profit will be 10Y. The total profit on selling packages of screw A and screw B is 7x plus 10y. Therefore, the profit function is 7x plus 10y, and we have to maximize the profit, then the objective is to maximize this z, and z is a objective function. We will discuss this later again. Now, after denoting the unknowns and writing the non-negative constraints, we have to write a table. Here in the table, first we write the unknowns x and y. What is this x? X is the number of packages of screw A. So, we have considered x is for screw A and y is for screw B, packages of screw B. Next, to fill further details in the table, we have to read the information given in the question. Each type of screw requires the use of two machines, an automatic and hand operated. Two different types of machines are used to manufacture screws. Further, it takes 4 minutes on automatic and 6 minutes on hand operated machine to manufacture a package of screw A. They have given time used on different machines to manufacture screw A. So, for the screw A, this is the column of screw A. Screw A takes 4 minutes on automatic machine and 6 minutes on hand operated machine. So, I can write the details of the time used on different machines on this row here. I will write in the first row time on automatic machine. They have given time in terms of minutes. So, I will write its unit as minutes. Similarly, another machine, time on hand operated machine. This is also in minutes. Screw A uses 4 minutes of time on automatic machine and 6 minutes on hand operated. Similarly, it takes 6 minutes on automatic and 3 minutes on hand operated to manufacture a package of screws B. 6 minutes on automatic, 3 minutes on hand operated for screw B. 6 minutes on automatic, 3 minutes on hand operated for screw B. Next, each machine is available for at most 4 hours on a day, on any day. So, here we have a restriction that we can use the machine only up to 4 hours. Maximum availability of the machine is 4 hours. Each machine, both automatic and hand operated machine, can be used maximum for 4 hours. Maximum means less than or equal to, within 4 hours. Within 4 hours. But observe here, the unit of measuring this time on the machines are in terms of minutes, but here they have given in terms of hours. We convert this hour into minutes. For 1 hour there are 60 minutes, for 4 hours there will be 240 minutes, that is 4 into 60. Similarly, for 1 hour it is 60 minutes, for 4 hours 4 into 60, 240 minutes. Each machine is available for maximum of 240 minutes. You can write this column as availability. And similarly, here you can write the column head as resources, or you can leave this as it is. Further, the manufacturer can sell a package of screws A at a profit of rupees 7. We have a profit on selling one package of screw A and screw B. So, I will write another row for profit. We can write this as a profit per package, and profit is measured in rupees. For selling one package of screw A, profit is rupees 7. For selling one package of screw B, profit is rupees 10. We have filled this table. Now observe here, this table gives the clear information about the given question and it covers all the information. Screw A takes 4 minutes of time on automatic machine and 6 minutes of time on hand operated. For screw B, it takes 6 minutes on automatic and 3 minutes on hand operated. And machines are available for maximum. We do not write usual inequality sign for this inside the table. We use this sign while writing the inequality. Each machine is available for 240 minutes, and also I have written the profit. Profit on selling one package of screw A is rupees 7 and one package of screw B is rupees 10. Next we have to determine that assuming he can sell all screws he manufacture, how many packages of each type should the factory owner produce in a day in order to maximize his profit. We have to find number of packages of each type, that is value of x and y, that has to be produced in a day so that the profit is maximum. Now we write the mathematical form. Each machine is available for at most 4 hours. I will write this here. Each machine is available for at most 4 hours on any day. Therefore, we have the constraint 4 into x. For one package of screw A, time used on automatic machine is 4 minutes. Then for x packages, it will be 4x. For one package of screw B, time used is 6 minutes. Then for y packages, the time used will be 6y. The total automatic machine time is 4x plus 6y. And machine is available for at most 4 hours, so it is less than or equal to 240 minutes. We can solve this inequality further by taking 2 common and cancelling 2 on both sides, or you can leave this as it is. If I take 2 common, we get 2 into 2x plus 3y is less than or equal to, I can write 240 as 2 into 120. 2 get cancelled on both sides and we get the inequality 2x plus 3y is less than or equal to 120. We can reduce the same inequality into this form, and the time used on hand operated machine for manufacturing one package of screw A is 6 minutes. Then for x packages it will be 6x. Time used on hand operated machine for one package of screw B is 3 minutes. For y packages it will be 3y. Total time used is 6x plus 3y, and machine is available for at most 4 hours. This machine is available for maximum 240 minutes. Again here I can take 3 common. 3 into 2x plus y is less than or equal to 240 can be written as 3 into 80. 3 get cancelled. We get 2x plus y is less than or equal to 80. These two are constraints. And then the objective function profit on selling x packages of screw A and Y packages of screw B is Z is equal to, for one package profit is rupees 7 on selling screw A. For X packages it will be 7x. Profit on selling one package of screw B is rupees 10. For Y packages it will be 10y. This is the profit function. So now I will write its mathematical formulation. Therefore, the mathematical formulation of the problem is, we have to maximize the profit, maximize Z is equal to 7x plus 10y, subject to the constraints are here. 2x plus 3y is less than or equal to 120. Another constraints, 2x plus y is less than or equal to 80. And remember to write non-negative constraints. This is the mathematical formulation. Now we use graphical method to solve this problem further. We solve the inequalities one by one. For the first inequality, for the inequality 2x plus 3y is less than or equal to 120. Again we follow two steps, that is to find the points on the line of the inequality and to find the solution region of the inequality. To find the points we write the equation of the line. The equation of the line is 2x plus 3y is equal to 120, call this as equation 1. Now substitute x as 0 in this equation, we get 3y is equal to 120, y is equal to 120 divided by 3, which is 40. And put y as 0 in this equation, we get 2x is equal to 120, then x is equal to 120 by 2, which is 60. Therefore, the line passes through the points 0, 40 and 60, 0. These are the points. Next, to find the solution region, put x is equal to 0 and y is equal to 0 in the inequality. 2x plus 3y is less than or equal to 120. We get 2 into 0 plus 3 into 0 is less than or equal to 120. 0 less than or equal to 120 is true. Origin is satisfying the inequality, therefore the solution region lies towards the origin. Similarly, the second inequality is 2x plus y is less than or equal to 80. I will write that here. For the inequality two x plus y is less than or equal to 80. the equation of the line is two x plus y is equal to 80. Call this as equation 2. Now put x as 0 to find the point. When x is 0, we get y is equal to 80. Put y as 0 in this equation, we get 2x equal to 80, x is equal to 80 by 2, which is 40. The line passes through the point 0, 80 and 40, 0. Next step is to find the solution region. Put x is equal to 0 and y is equal to 0 in the inequality. 2x plus y less than or equal to 80. We get 2 into 0 plus 0 is less than or equal to 80. 0 less than or equal to 80 is true. Therefore, the origin satisfies the inequality. The solution region lies towards the origin. Now the next inequality is non-negative constraints. This says that the feasible region lies in the first quadrant. Since x, y greater than or equal to 0, the feasible region lies in first quadrant. I had discussed all the inequalities. Now we have to plot the graph. Here x can take the value 0, 40 and in the first line 0, 60. So I will mark the points up to 60 or 70 starting from 0, 10, 20 on the x axis. 0, 10, 20, 30, 40, 50, 60, 70 and y takes the value 40, 0. On the second line it is 80, 0. So I will mark the points up to 80 or 90. 10, 20, 30, 40, 50, 60, 70, 80, 90 on the y axis. And here x dash, y dash denote negative direction of x and y axis respectively. O is the origin. Remember to write the arrows. Now the points on the first line are 0, 40, x 0, y 40. Another point is 60, 0, x 60, y 0. Also, the inequality includes the equality sign. So, we draw a solid line passing through these points. I have drawn the line and its equation is 2x plus 3y is equal to 120. I will write the equation. 2x plus 3y is equal to 120. Now the points on the second line are 0, 80, x 0, y is 80, x 0, y is 80. Another point is 40, 0, x is 40, y is 0. This inequality also includes the equality sign, so I draw a solid line passing through these points. I have drawn the line and its equation is 2x plus y is equal to 80. I will write it here. 2x plus y is equal to 80. Now, the solution region for the first inequality is The solution region lies towards the origin. This is the line for the first inequality. Origin lies below the line. The solution region lies towards the origin means the solution region lies below the line. For the second inequality, the solution region lies towards the origin. Origin is this side, then the solution region lies towards the origin. Now the common region for both of the inequalities is below both of the lines towards the origin. Also, we have non-negative constraints which says that feasible region lies in the first quadrant. So, we restrict the feasible region only in the first quadrant and we rub the remaining shaded region. I will shade the feasible region. This is the feasible region and rub the remaining shaded region, and this lies only in the first quadrant. The feasible region is bounded and the corner points are here origin. Let us mark this point as A. Coordinates of this point are 0, 40. Mark this point as B and this point as a C. Coordinates of this point are 40, 0. Here point B is the intersection of these two lines. So, the coordinates of this point are obtained on solving these two equations. I will solve these two equations. Observe here, the coefficient of x are equal in both of these. So, I will directly subtract equation 1 from equation 2 or equation 2 from equation 1 so that we can cancel x and we get the value of y. I will subtract equation 2 from equation 1. Equation 2 is here and equation 1 is here. I will write equation 1 minus equation 2 gives equation 1 is 2x plus 3y is equal to 120. Equation 2 is 2x plus y is equal to 80. On subtracting, x get cancelled, 2x to x get cancelled, 3y minus y is 2y, 120 minus 80 is 40, 2y is equal to 40, then y is equal to 40 divided by 2 which is 20. Now put y is equal to 20 in equation 2. This is equation 2. We get 2x plus y is 20 is equal to 80. 2x equal to 80 minus 20 is 60. X is equal to 60 by 2 is 30. Therefore, the coordinates of point B are x, y 30, 20. And we write the feasible region is bounded feasible region is, from the graph you can observe here, feasible region is OABC. It is a closed figure OABC. The corner points, I will write here, and the corner points of the feasible region are one is origin 0, 0, another is A of 0, 40. I will write them one by one. Origin A of 0 comma 40. Next B of, we have determined the coordinates of the point B. It is 30 comma 20. And last corner point is C of 40 comma 0. After finding the coordinates points, the next step is to evaluate the value of z at each of these corner points. For that, we write one table containing two columns. One is for corner points, another is for the objective function z. The objective function is 7x plus 10y. Corner points are here: origin A of 0 comma 40, B of 30 comma 20, and C of 40 comma 0. Let us evaluate the value of z. Put x as 0 and y as 0 in this expression. We get 0 plus 0, the value of z is 0. Put x as 0 and y as 40, we get 0 plus 10 into 40, which is 400. Put x as 30 and y as 20. In this equation, we get 7 into 30 is 210 plus 10 into 20 is 200. I will evaluate here. 7 into 30 plus 10 into 20, 210 plus 200 is 410. Put x as 40 and y as 0. 7 into 40 is 280 plus 0. These are the values of z. The objective is to maximize the profit function. So, we check for the greatest value here. Greatest is 410 and this will be the maximum value. Then we conclude that the maximum value of z is at the point B of 30 comma 20. But here we have to find the unknowns x and y at which the value of z is maximum. Here the value of z is maximum at 30 comma 20, that is when x is 30 and y is 20. What is x? We already know that x is number of packages of screw A, y is number of packages of screw B. So, z will be maximum when x 30 means number of packages of screw A is 30 and number of packages of screw B is 20. Then we can conclude the same as z will be maximum when the factory manufactures and sells 30 packages of screw A and 20 packages of screw B. So, I write the conclusion. Therefore, the factory should manufacture or should produce 30 packages of screw A and 20 packages of screw B to get the maximum profit. Maximum value of z is nothing but maximum profit of rupees 410. This completes the solution.